ओके केमिकल काइनेटिक्स की तरह सुपर लेक्चर लेक्चर नंबर 10 in fact sigi video sida I'm going to solve some problems from first order reaction. So the heading will be questions based on first order reaction. In fact question se khara koina hajik tawdur se ko proof ni. So question number 1, for a first order reaction, prove that T75% hasi first order reaction magi 75% complete tawda changba matam duni ko sigisi this is equal to 2 times of T50%. We need to prove this relation, and this is true only for a first order reaction. And second relation that can be proved is T99.9% is equal to this is equal to 10 times of T50%. T50% is also called half-life of a reaction. And the third relation we can prove for first order reaction is T99% is equal to 2 times of T90%. These three relations can be proved for a first order reaction. So first of all, let me prove this one. T75 is equal to 2 times of T50%. Okay, so to prove, let me erase this page. Let me clear this one. Okay, so this is our solution. So I'm going to prove the first relation. So for a first order reaction, we have this integrated equation that is T is equal to 2.303 divided by K log A naught by A. So A naught is the initial concentration of the reaction, and the A is the concentration of the reactant left after time, this T, right? So this is the first equation. So for 50% completion of the reaction, we need to substitute T by T50% and A by A naught by 2, because when 50% of the reaction is complete, the amount of the reactant left will be equal to half of the initial concentration. A naught is the initial concentration, right? So for 75% complete, we need to substitute T by T75% and A by 25%. A is the reactant concentration which is left. So if 75% of the reaction is complete, the remaining is 25%, right? So 25% means 25 by 100 of R naught. Sorry, this is A naught, right? A naught. Now let me write this for 50%. T 50%, 2.303 divided by K log of A naught by, instead of A I need to write A naught by 2 for 50% completion of the reaction, because this is T 50%, right? A naught by 2, so this A get cancelled out and we have only log 2 here, right? So this is equal to 2.303 divided by K log 2, right? This is our equation number 2. And for 75% we need to substitute this T by T 75. T 75% is equal to, in this equation, 2.303. K is constant, right? K is the rate constant of the reaction. This will be constant unless the temperature is changed, right? So log A naught by, instead of this A I need to substitute by 25 A naught by 100. 25 A naught by 100 is 1 by 4, right? A naught by 4. So here I can write A naught by 4. So this cancelled out, and that this is okay, 2.303 divided by K, and we get log 4 here, right? So log 4 can be written as log 2 square, right? And that 2 which is in the power can come in front of this log from the property of logarithm. So I can write like this: 2.303 divided by K log of 2 square, like this. So this 2 can come here, so I can write 2, and this whole term 2.303 divided by K log 2 is equal to T 50% from equation number 2. So I can just substitute this whole term as T 50%, right? So therefore T 75% is equal to 2 times of T 50%, right? So we have proved this relation, right? Okay, let me prove the second one again, but in a different way, right? Okay, let me erase this. Let me save. I don't know where it's saved, but okay. Now question number 2, right? Question number 2, that was B, I think. I need to prove the 99.9% is equal to 10 times of T 50%, right? So we just write this relation for a first order reaction. K is equal to what? 2.303 divided by T log of A naught by A. This is the integrated equation of first order reaction. Now for 99.9% of the reaction, we need to substitute this T by T 99.9%, right? And A naught, A will be equal to if 99.9% is complete, then 0.1% is remaining of A naught, right? And this is equal to 0.1 by 100 of A naught, and this again can be written as A naught by 1000, right? A naught by, oh go dear, A naught by 1000, right? This is the value of A for 99% completion of the reaction, and for 50% completion of the reaction, A will be equal to what? A will be equal to 50%, right? 50% of A naught, and this is equal to 50 by 100 of A naught, and that is equal to A naught by 2, right? Okay. Now this is the value of A for 50% completion of the reaction. Now I put this relation K of 99% completion, sorry, back, okay, 99.9% completion of the reactions, K will be equal to K of 50%, because K does not depend upon the extent of the reaction, right? It only depends upon absolute temperature, so K will remain same. So in this relation I just put the values of K at different times, right, and at different concentrations. So K I'm writing for 99.9% complete of the reaction, right? So this is 2.303 divided by T will be the 99.9%, right? Log of A naught is what? A naught is A naught, and for 99.9% complete of the reaction, A will be equal to what? A naught by 1000. This is A naught by 1000, right, is equal to, for 50% completion of the reaction, let me substitute A naught by 2, right? So 2.303 divided by T will be T 50%, and the log of A naught by 2, like this, right? So this 2 gets cancelled out, A naught cancelled out. So now okay, this is 1 by T 99.9%. This is 100, this is 1000. Log of 1000 is 10 to the power 3. 3 can come here, and this is 1 by T 50%, and this is log 2, right? Log 2. Okay, now this can come here, or this can come in here, right? Let me bring this T 99.9% here, so that it goes up. T 99.9% divided by T 50%, this is 50, right? And here log 2 is 0.301, and here this must be divided by log 10 to the power 3, and log 10 to the power 3 is 3 into log 10, and we know that log 10 is 1. So 0.3, this is approximately 0.3, right? 0.3 divided by 3, No, this has been wrong. This step, I have written this step wrong. Let me erase a few things. This is wrong. Okay, now here I bring this t 99% here, so I need to bring this log 2 below log 10 per 3, right? This is 3 log 10 divided by log 2, like this, right? So this 3 into log 10 value is 1 and log 2 value is 0.301, right? So if we divide 3 by 0.3 approximately, this is approximately 10, right? So therefore t 99.9% is approximately equal to 10 times of t 50%, right? I have proved two relation for a first order reaction. So the third proof is left for my viewers. Please solve that proof and make a photo from that, and you please comment in the comment box, right? So let me go to the next question, next application, next question of first order reaction, right? So let me erase this one. Second type of question here I can solve is, okay, for a first order reaction, K is 2 into 10 power minus 4 per second. For example, calculate so let me write two questions here. First is the half-life of the reaction. This is very easy. Half-life of the reaction. और दूसरा क्वेश्चन है the time thing, calculate the time taken for 75% completion of the reaction. So many questions हम जा रहे हैं. And the third question can be calculate the time okay, calculate the time taken for the reactant to reduce its to reduce to 1/16 of the time for the reactant to reduce to 1/6 of the initial concentration. So many question do hangba yai ko ado first order reaction is given and the value of rate constant is also given. So half-life of the reaction is very easy, because for a first order reaction we know that, let me solve this question. Okay, Let me change the color. Okay, solution. The first one, for a first order reaction, half-life is equal to 0.693 divided by k. This is the relation for half-life and rate constant of a first order reaction. So we know the value of k, which is given in the question. This is 2 into 10 power minus 4. So I can easily substitute this value. 0.693 divided by k means 2 into 10 to the power minus 4 per second, right? So unit of half-life will be second. 2 na se divide to we get 0.3 4, then it comes 13 means 6 5 something. 0.3465 into 10 to the power 4 second, or you can just write 3465 seconds. So this is the half-life of this reaction, first order reaction, right? So now I can calculate the time taken for 75% completion of the reaction. That has been proved already in this video, in the first question, that the 75% is 2 times of the 50%. Half-life is the 50%, right? This half-life is nothing but the 50%. So the second question, the 75% is equal to 2 times of the 50%. So 2 times of this 3465 second, that is, I think this, right? 0.396 second, double of this one, right? So this is the time taken for 75% completion of the reaction. Okay, let me check the time for the video, the duration of the video. This is already 22 minutes. Okay, I can solve the third question also. So let me erase this part. Let me clear this space, right? Okay, the third question is, here we are given value of k is 2 into 10 to the power minus 4 per second. So we need to calculate the time taken for the initial concentration to reduce to its 1 by 16th value. So let n naught be x. So this implies a will be x by 16, right? Now for a first order reaction, T will be equal to 2.303 divided by k log of a naught by a. So we can substitute the value of k and the a and n naught, right? K is 2 into 10 to the power minus 4, and this is 10 to the minus 4, right? And the n, a naught is x. I'm substituting a naught by x, and the a by x by 16, x by 16, x get cancelled out, and we get this 2.303 divided by 2 into 10 to the power minus 4 log of 16 is 4 square of 4, or you can write 16 2 into 2 into 20 means 2 give power 4, right? So this 4 can come here. 2.303 divided by 2 into 10 to the minus 4. This is 4, and log 2 give value is, let me write log 2 for this line. This is 2, so you can get the rook 6 4, right, into 10 to the power 4, and log 2 give value is 0.3. Let me take 0.3 only so that I can multiply without using the calculator, right? So 18, right? 6 into 3 is 18. 3 0 is 3, that is 1. Now again 16, and right, I think this is correct. 1.3818 into 10 to the power 4. Guys, please check this is whether this my calculation is correct or not, okay? Or simply I can write 13818 second. Okay, this is the answer. This is the time taken to reduce the initial concentration to its 1/16th value. Okay, 13818 second. I think this is correct. 3 na terkumtraimpan. Correct, terkumtraimpan. I think this is correct, right? So 13818 second is the answer. Okay guys, for today let me complete my video here. Please like this video, share this video to your friends if you like, and if you are new to the channel, please subscribe. Thanks.